Oh, the BS and
No?
I guess if you're in that already, you can afford a party.
Alright, hello everyone. We'll get started now. Okay, so last chance. Has anyone not yet filled out the sign-in form for attendance? Anyone still need it?
Yes.
Okay.
It's fine if you don't do it right now. I'm pretty sure it's at the end as well.
We can also just come back to the slides.
Yeah.
Yeah. Alright, so welcome to Micromouse.
First, we're going to go over a little introduction of me and Arunan. Hi, my name is Parth. I'll be one of your Micromouse leads this year. You can disregard this third thing. It's not, I don't think it's even true. But some of my, some things you should know about me is that the mouse that I competed with last year was called Bigger Chunky, aptly named after a spoiled can of milk that we left in our dorm over winter break. And some of my hobbies include chess and badminton.
Alright, and I'm Arunan, the other Micromouse lead, and don't worry about this insertion number 14 reference. Maybe if the DAV leads next year keep up the reference, you'll know about this. And I love Legos and anything to do with Legos and anything also to do with Star Wars. Don't talk to me about that. I'm always here and open to listening. And we're just walking in. We started the lecture, so. Okay, so first we'll go over some details and logistics. So first of all, regarding the deposits. So please send $50 to the UCLA IEEE Venmo. But I will iterate again, as we also put in the project applications. If for some reason, or if due to a financial burden, that you cannot pay the full $50, please reach out to us for a deposit reduction, and we'll give it to you on a no questions asked basis. And please also join our Discord, as it's our main method of communication, so that's how you'll hear any updates from us, and also if you need any help, we can help you up through Discord. And add the Micromouse role to yourself so you can get our announcements, and also see the Micromouse section. And if you haven't joined already, please join using the link. But we can also just bring up this QR code later on. You guys haven't joined.
All right, so let's go over what today's topics will be. So the main point of today's lecture is to go over how we do power delivery in Micromouse. So we're going to be going over the batteries, over what a voltage regulator is and how we use it for Micromouse, and over battery safety. Along with that, we're also going to be briefly touching the different softwares that we're going to be using throughout the program, including Fusion 360, which we'll use for PCB and schematic design, and the STM32 IDE to program your microcontrollers. Oh, and then also we'll be going over the syllabus. So first, let's go over the batteries.
So there are different types of batteries to begin with. So we have these very bulky, heavy lead-acid batteries that are cheaply easy to charge, but of course we can't fit this onto a small robot. And then we have these nickel metal hydride batteries, which have a limited lifespan, and also they have a limited output, but they are cheap and easy to charge. And then we also have lithium-ion or polymer batteries, which are very dense, energy dense, meaning that they can have a lot of power output, and they also have like a wide range of form factors, meaning like shapes and their sizes. And then they also are, but they are expensive, and also have complex charging methods, which may have to be tailored to your specific use. But as part of the same, we will use.
So the batteries that we're going to be using in Micromouse are 2 of these lithium polymer or LiPo batteries. Now, here are some specifics about the batteries that we're going to be using, but really the most important things that you should take away from this slide are that each of the batteries is 3.7 volts, and if we put them together, we can get a series voltage of 7.4 volts, which is like more than enough to power our motors. So I think our motors need like 6 volts to power them, so putting 2 batteries together should give us more than enough power, or more than enough voltage to run the motors.
And if you only use one battery, which will only provide 3.7 volts, we would not be able to run our motor at full capacity, thus resulting in a lower speed. And now battery safety.
Yeah, so basically for battery safety, just don't do dumb things. Don't like take a screwdriver or a pencil and just like start stabbing your battery. Don't try to solder on your mouse when the batteries are plugged in or if they're like really close, because that might cause them to, well, it might cause you to lose your hands or something, I don't know. But yeah, just, if anything, if you think your battery's looking a little suspicious, like if it's getting like puffy or squishy, just let us know as soon as possible so that we can take care of the battery.
And also, if one of the wires gets disconnected from the battery, please do not try to resoldering yourself. Just let Neo Parts know, and we'll do it for you, or we'll give you a new battery, which is much simpler. And so some basic tips on battery handling. So use the charger that we give you, which looks like this and is this. So the thing is, you want to keep it at a optimal, like at a specific range of charge, and so that means don't discharge it below 3 volts per cell. So basically, if the Micromouse starts acting slow or isn't responding as well to what you're responding as well to the program, then that means it's probably on a low battery and you want to replace it or recharge it. And so a good lower limit is 3.4 volts per cell, and charge both when they get low. And again, as Parth mentioned, if there's anything sus about the battery, just let us know immediately.
Oh, actually, one thing that I want to add to this one. If you want to figure out what voltage your battery's at, you could just use a multimeter, and there's like 2 leads at the bottom of the battery, or at the bottom of the charger. So you could just like plug the battery into the charger, and then just like touch the 2 leads to the bottom to see what voltage each battery's at.
And now voltage regulators.
Okay, so a lot of you might be wondering, what is a voltage regulator and why do we need it? Don't we want like maximum power going into the motors at all time? Well, that's not always ideal. So basically what a voltage regulator does, evident in its name, is that it regulates the voltage that the microcontrollers get from the batteries. And the reason why we do this is because when we turn on and off the motors, it can lead to like spikes or drops in the voltage that the MCU gets, which is a problem because if the MCU randomly gets a drop in voltage, it could just restart the MCU, causing your mouse to like restart trying to solve the maze. So it'll just like mess everything up. So the way that we combat this is with a voltage regulator, which gives your MCU a nice stable 3.3 volts.
And as you can see right here, so this will be like the input from the battery, which is like unstable and oscillates a little bit, but then your output is a stable 3.3 volts, which the MCU can take. And now some more about linear voltage regulators. So you can safely just ignore the second bullet point because it's a little complicated and requires some knowledge in a more complicated class. But for the first bullet point, so just imagine that it behaves like a variable resistor. So this means that it will drop whatever voltage that it takes in to the necessary or desired voltage needed for the microcontroller unit or the MCU. So, for example, if it's at a really high voltage peak, then it will drop it to 3.3 volts. But if it's at maybe like a lower voltage peak, it will still drop to 3.3 volts. Thus, it's a variable resistor because it will drop the voltages accordingly. And again, it just essentially just burns off any excess voltage that will prevent any harming of the components on the Micromouse.
Actually, before we keep going, does anyone have any questions about what we've gone over so far? All right, awesome. Okay, so the voltage regulator that we're going to be using on the RAT is that one that you can see there. It's a through-hole component, which means that you literally just like put the wires through the PCB and solder the bottom. It outputs a 3.3 volt, 800 milliamp output current, which is exactly what we need to power our microcontroller unit. Now, the Nucleos or the nuclear boards that you will be using for your RATs, they do have their own voltage regulators, but we're not going to be using those because when you make your actual mouse, you need to use your own voltage regulator because when we make the mouse, we're not going to be using the nucleo boards. We're going to be using like the actual MCU. And over here you can see the schematic for the voltage regulator. during your voltage regulator assignment, you'll actually learn about what these capacitors do, but does anyone already know or have an idea of what the purpose of these two capacitors are? Yeah?
For noise filter.
Yeah, so exactly. So they're decoupling capacitors used to make sure that the signal is clean.
And also, so as Pard said, he referred to a Nucleo board and also the MCU chip. So when you're making the RAT, so like your first iteration of the Micromouse, you'll be using this big white Nucleo board. And essentially, it has, like Pard said, it has a built-in voltage regulator. However, when you make your Micromouse, make your own design in winter quarter and spring quarter, the chip that you will use to control your Micromouse will fit on the tip of your, the microcontroller will fit on the tip of your finger. So it's really small and thus doesn't have a built-in linear voltage regulator. So that's why we want you to learn how to make one right now instead of later on. Has anyone have any questions about this slide or any of the components that you see here? Just in case. So V-in is basically just the input, the voltage input from the battery. V-out is what comes out of the linear voltage regulator, and then this is just the symbol for ground. And these are the schematic symbols for capacitor. And this, of course, is the linear voltage regulator itself. Any other questions? Please don't be scared to ask. Everyone is here to learn.
I actually want to. Why do we need a capacitor at the CL, like the VL? Like, it's just a stupid question.
No, that's not a stupid question. Basically, if you have capacitors for the in and out, it makes sure that like whatever signal that it's outputting is actually like always 3.3 volts with like very little noise, if any at all. You'll learn about it a little bit more in the actual assignments that you do. So like when you make this schematic in Fusion 360, like we'll talk about exactly what the purpose of each of those capacitors is.
So even though like the linear voltage regulator's purpose is to like kind of filter out the noise and like make it a stable output, it may not be always perfectly stable. So which is why we also have another decoupling capacitor just to make sure it's truly stable. Any other questions? That was a great question.
Yeah.
Yep.
Is it possible to use SMTs instead of through-holes?
Yeah, so most teams for their mouse actually go with the SMT linear voltage regulators. We're just using through-holes, or along with through-holes, we're going to be using like slightly bigger components for the rack because for a lot of people, this is going to be like their first time soldering. And soldering SMD components can be really painful, especially if they're smaller. So we're just going to be going with the big one.
And just as clarification for anyone who's wondering like what does through-hole mean and what does SMD mean? So basically through-hole components, so as you can see for this voltage regulator, these are the three legs that it has, and it literally will go through the board. As you can see, like these things sticking out from the bottom. But then for other components, such as these tiny components, I know you guys probably can't see, but you guys can come up and see later. These tiny capacitors that you see at the front here, you can't see their legs because they don't have any legs that go straight through the board. So they're literally just mounted directly onto the top, but don't have anything going through the board itself. And SMD stands for surface mount.
Oh, SMT, surface mount technology.
Oh, okay.
Yeah.
Any other questions? All right.
Oh, did you have a question? Okay.
Okay, so now going over the software. So obviously electrical engineers love to code, and maybe some of you might recognize these two faces on this slide. If you guys don't know who these two people are yet, you will find out, don't worry.
Well, actually, maybe you won't find out about Professor Egger at the top. Because he might not be here next year, but we'll see.
Okay, so we'll be using the STM32 IDE to program our Micromouse. So it's an Eclipse-based programming suite, and it is definitely more powerful than the Arduino IDE, and gives you a lot more options. And it's much more usable and much more complex than Arduino IDE at the same time, obviously because STM is a very STM products are used in industrial applications, so that's why it's much more complicated. And the language that we'll be programming our Micromouse in is C. So I know a lot of you guys, or maybe a lot of you guys, have not coded in C. But trust me, you will come to maybe love it as I do, but most of you probably won't come to love it. But you'll still be coding in C anyways. But C is a very low-level language, and it's definitely a very good skill to know as an electrical engineer or computer engineer. And then you'll be doing your schematic design or PCB design. So schematic is like the electrical circuit you saw earlier of the linear voltage regulator, that was a circuit schematic, and then the PCB design PCBs are just like the printed circuit boards, and that's literally just this black board that you see right here. And Autodesk Fusion 360 allows us to do both schematic and PCB design. And now just go for the syllabus. Oh, yeah.
How do we get the software?
So we'll just the assignment 1B that we'll release after this lecture, we'll go over how to install the software and everything. Yeah. Any other questions? Oh yeah.
What is assignment 1A?
So assignment. Okay. All right. So we'll go with this at the end of the lecture, but might as well just bring it up now. So assignment 1A is where you will start soldering components onto your PCB. So that way you can get your Micromouse powered up and you can like make sure that it actually works. And then so the A assignments are usually associated with soldering components on and programming the Micromouse, whereas the B assignments are associated with schematic design and PCB design. And you do the assignment, so you do the A assignments with your team, so you guys do it together, and then your B assignments are on your own, so each person does it on themselves. Any other second question?
Oh, I mean, I guess we'll find out later. But like, do we have like free Autodesk like subscription with like
Yes. So all of you will have a free student license for both. I don't think STM32 IDE requires it.
It doesn't need a
Yeah.
license.
So that's free anyways. So, but this you'll have a free license. Any other questions? All right. Now so for the syllabus. If there's any questions about the syllabus, because we can go over it, but I mean, it is no questions about it.
I think we should still go over it.
Okay, sure. 1 second, I have to pull it up. Okay, so here's syllabus. Maybe I'll zoom in just in case. There we go. Okay. So just to begin with, here are our contacts. You guys need to reach out to us on Discord or our emails, but we prefer, pretty please, reach out to us on Discord because it's much easier, and you also just check it like way more often. Also because we have like notifications on Discord on all the time, so it's much easier to use.
Again, if you haven't joined the Discord already, please join the IEEE at UCLA Discord.
Like literally after this lecture, like join, just join. And then just to go over like the plan for the year. So we have, obviously we have 3 quarters in how our school works. Yay. So first quarter, so this quarter, fall, we'll be making a rat. So if you're wondering why they call it rat, don't worry about it. It's just something that's stuck with like for years, so we just call it the rat. But we'll be providing you a PCB and all the components that you need to make a fully working Micromouse, or in this case, the rat. And we'll also teach you how to code it completely. And you will have a working Micromouse or rat at the end of this quarter, and you'll be able to participate with it in our fall rat competition at the end of this quarter and win some prizes.
And some of the lectures and assignments that we're going to be giving you guys will cover things like schematic design, or not PCB design yet. We're going to be going over the power, motor, and IR sensors, and like the electronic designs for all of those, how they work, stuff like that. We're going to be going over embedded software, but like not as deeply as we will in next quarters. And we're also going to be teaching you guys how to solder.
And just also to add on, so basically this, how Micromouse works is very fun heavy, just to give it to you straight. So because we're literally teaching you everything that you need to know about Micromouse and how to make a Micromouse in this quarter itself. So that way next quarter we can like let you guys go and make your own Micromouse designs completely from scratch. So this, if you can get through this quarter, it'll be great. And we fully believe in all of you guys. Like just make sure you guys stay on top of the assignments, make sure you guys stay on top of the soldering. Parth and I are always here to help you, along with like literally 3 generations of other Micromouse leads, and we'll all be able to help you. And so if you have any questions, just let us know. And Parth can describe the winter and spring.
Yeah, sure. So in the winter, your main goal is just to finish the PCB for your actual mouse that you're going to be using in AAMC at the end of the year. So the main things that you're going to be learning in winter quarter are how to design your PCB, and in addition to that, there's going to be some guest lectures from this project's faculty advisor, Professor Garesifard, and he's a controls professor here at UCLA. And for spring, your main goal is just to finish your mouse, and spring is also going to be very software heavy, so that's when, or we'll start it in the winter, but most teams finish their May-Salvin algorithms in spring, so get ready and get excited to look at code for hours on end.
It's not meant to intimidate you, just
Yeah.
hours of coding will be required. So some prerequisite knowledge, literally just if you can do if statements, functions, or loops, that's all you need to know. If you have questions about any of that though, please let us know. Of course, we're always here to help. But that's just all the prerequisite knowledge you'll need to know. We'll teach you everything else you guys need to know about the software. This is irrelevant to you guys now, but if you guys do plan on doing Micromouse returns in the future, you guys can redo Micromouse and make your designs even better and try for glory and victory again.
Okay, so this is actually kind of important. So we're going to be releasing a groups sign-up form later tonight, but basically the way that this program works is that you're going to be in teams of 3 people, and I think we're going to be pretty strict about the 3 people per team, unless there's like 2 people left over, in which case you're just a team of 2. But yeah, if you don't already have a team, don't worry about it. The social after this lecture is actually so that you can meet other people and create your own Micromouse teams. And even if you're not able to find people, then we'll just pair you up with other people who don't have teams. Yeah, that's basically it.
Also, please talk to me at the social. You know, we don't want to be lonely. We've talked a lot, but also talk to us so you can get to know all of you guys. And again, there's a $50 deposit, but if you're unable to make it due to being a financial burden, please let us know so that we can give you a deposit reduction. Again, it's a no questions asked basis because we don't want money to hinder you from doing a project, because we believe that everyone should be able to do a project if they desire.
Actually, one more thing to add about the deposit. We're also going to be releasing a form where you just like take a screenshot of the Venmo transaction and submit it so that we can keep track of who submitted what. Oh, yeah, okay. Another form, I'm sorry, there's like a lot of forms that you have to keep track of, but the final form, hopefully, that you need to worry about is the lab safety form. So basically, to be able to solder in the lab at all, you need to finish 4 lab safety trainings, and they're all going to be online. I believe we've sent the links to everyone already in the email that we sent out yesterday, but if you haven't, just let us know. And in the email, I think we said 3 trainings. There's actually 4 trainings. Sorry about that. But once you're done with the trainings, just download the completion certificates and submit it to the form that's linked in the syllabus.
Okay, so for the checkout policy, so this is regarding the assignments. So again, we highly recommend and desire that you guys finish your assignments on time. But in the scenario that you guys can't, please reach out to me in part, so that way we can give extensions. And just stay on top of the assignments is mainly for you guys, because if you guys put off the soldering or the coding too long, then it'll become like a 20-hour work week at the end of the fall quarter. So just to make sure that it stays like as a 3 to 4 to 5 hour commitment, please stay on top of the assignments. And again, the lectures are all recorded. Not only are these lectures recorded, but the lectures from like the past 2 to 3 years, or maybe 4 years of Micromouse lectures are recorded, so you guys can also reference those. And also the IEEE lab is open during all the weekdays from 10 a.m. to 6 p.m. And if Parth and I aren't there, please feel free to reach out to the other IEEE officers. It is more likely than not that one of them was probably a past Micromouse lead. And because there are just so many Micromouse leads that we still have in our IEEE officer board. And also just coming to the IEEE lab. And you can visit the IEEE at UCLA website to see when Parth and I specifically will be in the lab. Is there anything else you want to add?
Even if, actually, to add on to what Arun said, even if like the other officers haven't led Micromouse, most of them have done Micromouse, so you could always just drop by and ask anyone questions.
And then go for the workshop.
Questions.
What's the weekend schedule?
It's not open.
Oh, okay.
I mean, okay, there might be work sessions on the weekends, but we'll let you know about that in advance.
Although we do not plan on doing work sessions on the
Yeah.
weekends. Yeah.
Unless,
But we'll be available for text over the weekends, so you can still like talk, DM us and stuff for help. Yeah. And then, so besides the Micromouse lectures that we host, we will also have the work sessions. So we highly recommend that you guys come to them because these will literally be hours that Parth and I will be helping you guys finishing the assignments. And this is a great way to, like, again, ask Parth and I for help, get soldering done, get your coding assignments done. Any debugging, any issues like with debugging, come to Parth and I. We will help you guys out because it can get very nasty when you guys get to the PID section. Yeah, that's all. So just any questions about any of that? Again, please don't be scared to ask. All right. And yeah, thank you for joining us on this journey. And yeah, we promise you guys will love it. It'll be really fun. All right, back to the lectures. Okay, so do the light demo.
yeah, so now we're going to be just briefly going over how to upload, or a small walkthrough of what the STM32 IDE looks like. If I can. I got it. Actually,
Yeah. All right, 1 second. Sorry. Sorry, 1 second, guys. It takes a little bit to load. Okay, so this is Bruce Wallace. Should be a. Okay, so I know you guys probably cannot see or read it, but maybe that's for the better because it's my code that I'll be using to compete with. Just kidding, no. So basically, so here is, let me just, Okay, so I'll just be showing you guys the cube IDE while Parth gets his loaded up because we brought his Micromouse here today so that he can show you like it's like the whole Micromouse running, be able to see live expressions, which you guys probably don't know what means yet, but you will in a moment. And so again, cube IDE is what we will be using to learn. Cube IDE is what you'll be using to code your Micromouse, and again, it's all in C. So here I have like a few project names on the side. So I can just show you maybe like my first MM project, which is my rat code from last year. So I'll just close all these. So we first have this file called .ioc. It will take a second to load. But basically what a .ioc file is very convenient to use because it will show you the entire pinout map of your microcontroller or your nuclear board. All right, come on, load. Sorry guys. There we go. Okay, so this is, these are all the pins on the Nucleo, or like the microcontroller, the controller that we're using for your rat design. And as you can see, you can configure these pins to different modes. So these grayed out pins I'm not using, these green ones I am, and then I also named them for the different functions that they're doing. So for example, for the left IR emitter, this is for like the left motor encoder. And of course, you guys don't know what that means yet, but we'll be teaching you through the course of this quarter what they mean and what they do. And again, it's just very convenient compared to like Arduino or whatever else because there'll be a lot of pins that you have to sift through, and this just puts in a nice UI for you or user interface. And then you guys get to the actual coding part of it. So if we look into my source files, here's our main.c. And here's just like where you do some of the beginning coding assignments, and yeah, that's basically it for the Cube IDE. Just like an overview of it, but Parth will show you his code working in just a second. Are there any questions though while we're waiting? Are there any questions? None? Okay. And I know C may seem daunting at first because it's much more low level and complex than Python or whatever else you may have coded with, but again, just ask for help. ChatGPT is also out there. And then also just ask about the other officers. Okay. Okay, looks like. Wait, let's see if I can control the audio. Okay, try it now. I should have muted. There we go.
So, alright, so a little walkthrough, I guess, of the main.c file. So this is where you're going to be putting like all of your really important code, so like all the function calls that you need and stuff like that. But basically there's like this infinite loop here called the while one loop, and you can just like put whatever you want the mouse to continue doing over and over again in this loop. So for example, over here commented out is like what I would have uncommented if I wanted it to actually solve a maze, right? And it's like calling a bunch of other functions that are in some of the other files that you can see on the left. But one of the cool things that you can do with the STM32 IDE is that if you upload the code, to upload the code, you just click this debug button, by the way.
Again, we'll show you guys how to do all this in the assignment itself, so don't be scared if you can't figure out following through with it right now. We're just trying to show you like the features that you guys have with this Cube IDE.
Okay, so once you click debug, on the right over here, there's this thing called live expressions, which, there's this thing called live expressions, which allows you to see the values of certain variables that you want to see in real time. So for example, the top two over here are left and right counts, which represent how much the left and right motor has turned. So if we just run the code right now, and I were to like turn the right motor, you can see that it's changing the value for right counts. And if I start turning the left motor, it starts changing the values for left counts. So this is just like one of the many features of the IDE, but yeah, we just wanted to display it and thought it was pretty cool.
And we,
go ahead.
I would say we highly recommend it when you guys do debugging of your code. It's a very useful feature to know like any lab expressions. Maybe if you want to output the state of your program, you guys can also use the lab expressions.
Does the mouse have like a built-in potentiometer? Is that how it's getting the values? Like, do we need to know how to like fix something if like something breaks?
Okay, so I don't think the mouse has a potentiometer on board, but the way that it's displaying the left and right counts is based off of encoder values. So you'll learn about motors and encoders in a future lecture.
So the encoders, the encoders are not built in. So the encoders, we buy and attach it to your motor, and so that way you can keep track of how much the wheel is turning. And then the STM32 IDE has a very convenient library that allows you to configure those motors without having to like code it yourself, which would be really complicated. Any other questions? I saw another hand up. No? Okay. Alright, thank you for hanging on, guys. We're almost done, and pizza will almost be ready. Okay, so just some last minute reminders. Do your safety trainings. come to the work session on the 27th. Again, we'll put up another announcement about this, so don't worry about this right now. And then our second lecture is planned for October 24th. We'll put up more details about that in a future lecture. In a future announcement. But this is a very heavy lecture, and it's very, very useful to come to and know about and ask questions in. So please try to come to this lecture if you guys can. Because that's a lecture where you guys learn about how the Micromouse moves, how you keep track with movement, and how to actually code the encoders and motors.
And how the motor circuits look like, and how to make codes and things like that.
And so for now, so we will be assembling your rack kits like literally tonight, so we can give it to you guys for your next work session. And please go to the social right after this. That way you guys can form your teams, unless you guys have already formed your teams. But still come to the social, so you guys can get your pizza, and also talk to me in part. And again, complete your lab and safety trainings. Otherwise, you can't really do the project. And please also submit your deposits and reach out to us if you guys need a deposit reduction. And are there any questions? Nothing? Alright, if you guys have any questions like that you guys want to ask to everyone, just come to me in part individually. And thank you so much, guys. Thank you so much for sticking with us. And come to the social and dive into your lab right now.
So we'll just like follow over here together.
And if anyone didn't get the sign-in link at the very beginning, we'll put it up for like 20 minutes.